So this is where we left off in the previous video. We have, I'm just going to run this quickly. We have these lines which we drew, and we also have a screen, white screen or white background. So now we want to place the X's and O's in each of these rectangles. And to do that, we need a very important concept. So we're going to use Pygame rect, and that essentially now defines rectangular sections. And to define these sections, we're going to give the coordinates of the top left corner, as well as the width of the rectangle and the height of the rectangle. So for example, using this rectangle, this top left corner, it is at 100, 100. So those are the coordinates of the top left corner. Then we're going to give the width of the rectangle itself. So that would be this one specifically. It has a width of 100 from there to there, that's 100. Then from there to there, that's also 100. So I know that everything is 100, but don't confuse any of these things. The first thing we're going to pass into the function we're going to use, which is called rect. We're going to pass in the coordinates of the top left corner. So that would be the top left corner. So those are the first two coordinates, the X and the Y of the top left corner in these two positions. The next, we're going to have the width, and the next, the height. So we're going to give 100 and 100 for that top left corner for that specific one over there. And we are going to now have a different configuration for something else. So for position like this one here at this point, let's come to another position. Let's say this one there. So that would be at 100 still in terms of the X, and in terms of Y, that would be 200. So those are the coordinates of the top left corner of this rectangle over there. But the width is still 100 from there to there, and the height is also 100. So in rect, which is the function we're going to use, we're going to have the coordinates of the top left corner, 100, 200. Then we're going to have 100 and 100, which define that region. So just keep this in mind for the next section, where we're going to define each of these blocks, because we need to define them so that we can precisely place our X's and O's in those sections. So we're not drawing rectangles, we're just describing rectangular areas where we're going to place the X's and O's. All right, so to define those rectangular areas, I'm going to define another function, and here is our function. So I'm going to define, and I just decided to call this function define board sections. You can call it anything else that makes sense to you. Define board sections. And I'm going to use global variables so that we can use them outside this function as well. So top left box would be the one all the way at the top, and the top mid box would be the one after it or to the right of it. Then we're going to have top right box, which is the last one on the first row at the top. So I'm just describing my variable names, and I hope that makes sense. And this will be the middle row. So the middle left will be the leftmost in the middle row, and the mid will basically be the one in the middle of everything. Yeah, it's a bit weird, but let's just work with it. And the last one on that same row would be mid right box. Then finally, dealing with the last row, we're going to have bottom left box. Then we're going to have bottom mid box. And finally, we will have bottom right box. Okay, so these are our sections, and we haven't really defined them. So starting with the top row, we're going to have our top left box in that row, and we're now going to use the function which I just described. So we're going to give the coordinates of the top left corner, which are 100 and 100, as I just explained. And you can see here it says the width and then the height. So the width would be 100 as well, and the height would be 100. So these are squares and not necessarily rectangles, or they just have equal sides. The width and the height are the same. All right, so the next one would be this one, and the coordinates of its top left corner would be 200, 100, then the width and the height are the same. And I just go on and describe or define all the other rectangular sections, and I hope you can follow that. Okay, so it's very important that you have these defined correctly because we're going to track where the mouse clicks occur. So when a user clicks on a specific section on our page, we want to track where that is in coordinates. So we're going to capture the X and Y coordinates of the mouse click. Then we're going to determine if those coordinates intersect with these rectangles which we just defined now. So that was the point of defining these sections so that we can check if the mouse click intersects with these rectangular sections. And if it does, we can draw the X in that section. So you don't necessarily have to click in the middle or at the top or anywhere else. As long as your click is in each of these or any one of these, then that's where your X or O will go. So that was the point of defining these things. Once again, this is just a function. It doesn't work until we call it. So let's call the function just under our lines. So we don't have the X's and O's, so we have to get them. And I have images for that already. And I just give you guys the links to those images, or you can use any other image of your choice. So let's just call this section images. And I'm going to load these images into our program. So you can call the images anything. This just makes more sense to me. X image equals to Pygame, and this is how you'd load an image. And my image is called x.png, and the other image will be loaded in a similar fashion, and it is called o.png. Okay, so those are two images which we're actually going to place on the screen or in those sections which we defined just now. So we have lines and we have sections and we have the X's and O's, but they have not been placed on the screen yet. So how do you actually place them on the screen? So to determine whether we're placing an X or an O, we have to keep track of who's playing. We can start or we can have the X as the first player. So that's what that means. This is not a reference to these images. It is just a string which will help us to keep track of who's playing currently. So currently X is playing. So to place X on the board or in those sections, we're going to have another function and we can call it place XO. And in here, we're going to pass in those coordinates I talked about. So when you click on the screen, our program captures where you clicked and we can access those coordinates. So we can call this mouse X and mouse Y. Then this describes a position on the board, and we can use a tuple for this to basically describe where that position is. So I just decided to use a variable so that we don't have to copy this twice. So this is how we'd use this function, or this is how I would place the X's and O's on the screen. So if turn equals X, so if it is X's turn, remember we defined turn up there. So if X is playing, we're going to place the X on the screen. And this is how you do that. So that X image object, which we described up there, then we're going to place it at this position where we clicked on the screen. And that comes from our mouse click. All right. So remember that in here, we're looking out for mouse events. We're going to extract the coordinates, then pass them into this function to then determine where we're supposed to draw the X. So that's the flow, but we'll get to that in a bit. So else if it is O's turn, then we're just going to do the same thing, but we're now placing O on the screen. So we're going to pass in our O object at that position, which comes in there and is stored in that over there. Right? I left out a colon. Okay, so this is our function which will help us to place the X's and O's on the screen. We now have our lines, we have sections described, which will help us to place the X's and O's, and we have a function which places the X's and O's. It doesn't make sense to call it here because we don't have mouse clicks yet. So we're going to come down here where we handle our mouse events, and we're going to extract the coordinates of the mouse. Just like I'm clicking on the screen, it captures where I clicked on the screen in coordinates. So now we're going to extract those coordinates, then pass them in here to determine where we're supposed to draw the X's and O's. So that's what we're going to do next. So the first thing is we're going to capture mouse X and Y. You can split these up. Let's split them up just so it's easier. So mouse X would be event. So whatever event happened in the game, which would be a mouse click in this case. So you clicked on a mouse. So if one of the buttons, the left or the right, is clicked, or any other button in the mouse, then it basically captures that. And it also captures the position. And this is how you get hold of the position. You use the attribute POS, which is for position. And the first one will be the X coordinate of that event or the mouse click. And the second one is the Y coordinate of the mouse click. So you're now capturing these. All right. So the one in the first position, so it's a 0 index. So the one in the first position is the X coordinate of the mouse click, and that is the Y coordinate of the mouse click. So now we want to determine where the user clicked, and this is how we basically capture that. And we want to find a relationship between these coordinates and the sections on the board. So if the click was in this rectangle or in that section, then that's where we're going to draw the X or the O. And to do that, we need to check if this rectangle collides with the coordinates of the mouse. So if the mouse click is in that rectangle, it's called a collision, or we are saying that we're in that rectangle and we can place the X or the O in that rectangle. So let's define another function just so we don't have duplicate code again. So let's just call it is in section or is in rectangle. You can call it anything else you want. So we're going to determine if the mouse coordinates are in any particular section. So we're going to return. Now we're going to check if any of these basically collides with the mouse click. And also we're going to pass in the section as well. So let's pass in the section so that we determine whether the section collides with these mouse clicks. So that's how we're going to do it. I think this is a better way to do it. So by section, I'm referring to these rectangles which we defined up here. So we're going to pass each of them to figure out which one collides with the mouse click. So just to run the program again. So now, if a mouse click occurs in this, we're going to call this function and check if it's in that section. If the mouse click wasn't there, then we can't draw in there. So that's why this function is called is in section. So we're literally going to check each of these, all of them. We're going to check, okay, we detected the mouse click. Is it in here? Nope. Is it there? If it's there, place your X or O in that. So that's what this function is for. It basically determines if your mouse click collides or is in a particular section. So to use the function, you obviously have to call it, and we're going to check each and every section, unfortunately. So let's start. So if first check that we're going to have here is if is in section, and I'm calling this because this will return a true or false. So if it's in the section, it'll be true, and if it's not, it'll be false. So if is in section, we're going to pass in the section first of all, starting with the top left box. Then we're going to pass in the mouse X and the mouse Y as we defined our function up here. If you remember, we pass in a section and we're going to pass in all of the sections to determine where it is. Then we're also going to pass in the mouse click to that as well. So you're just going to do that. Then if it's in there, then we're going to place the XO in those coordinates, right? So that's what we're basically going to do. So we're going to now say that we want to place this using the coordinates of the top left. So in that rectangular section. So we're calling top left box X to extract the coordinates of the top left corner, which you described here. So these first two coordinates. And that would be better for us to properly place this image because it's also rectangular in form. So if we describe where it starts in terms of the top left corner, then we have more control over its placement. So let's do a quick summary of this section. We're capturing where we clicked on the screen, and we're passing in all of the sections, literally all of the sections. So we're going to have all 9 sections in these if statements. So if it's in the top left box, or if the mouse click is in the top left box, then we're going to place the X or the O in that rectangle. And the rectangle can be described using the top left coordinates. That's why we're using this to pass into the X and the O function. So that's what we're going to do. So else if, so we're going to go through literally all of the sections. So might as well just copy paste for the, let's have the next one in and just copy paste everything. We're basically just going to change the sections just to be quicker. It's not always a great idea to copy paste codes, but yeah, we're not about to type 9 sections over and over again. So let's see what we can do if you have all of the sections in here. So remember, it's top left box, then it's top mid. So you're just going to change these, top mid, then it's top right. Okay, now that we have these, they look a bit squished. So if you want to improve visibility, I guess you can just skip the space, just make sure everything's in order. But skipping the space just makes your while loop a bit longer. Okay, so let's make sure we have everything. So we're literally checking if the mouse click happened in any of those rectangles which we defined. If it happened in it, then place the X or the O in that rectangle. That's what we're doing here. So let's just make sure that we have everything. Top left, top left, top mid, top mid, top right, mid left, mid left, mid mid, mid right, then bottom left, bottom left. Then we have bottom mid, then bottom right, bottom right. So that's everything. So Now, we also have to change the turn. So if we place an X, next we have to place an O, and vice versa. So now done here, so we don't have to do it after playing or after each turn or after each placement. We can just do it here outside all of these if statements and just have it on the same line as, right? So turn equals to O if turn. So if X just played now, then we change turns to O. Otherwise, X is playing, which would mean that O previously played. So this is how you change your turns. You can also implement different logic over here, but just make sure that you change turns. So turn changes to O if X just played up here. Otherwise, if O just played, then it's X's turn next. So that's what we have. So we are mostly done with this video or this section where we just want to place the X and the O's. So let's see what we have, because we've done a lot and we haven't really ran our program. So let's run it and see what we have so far. So we still have our lines, still have our background. And now we want to see if what we did works. So if I click in here, I expect something to pop up. And as you can see, I have an X that pops up there. If I click in here again, okay, it changes the turn, but I can still draw in there. So that's an issue, but we'll fix that in a bit. And I did that intentionally, by the way. So now if I click there, that's where it shows. If I click there, that's where it shows, and so on. And if I fill everything up, then, okay, this one's not responding. This is bottom mid. Let's see if you have bottom mid. Do we have bottom mid box? We have it there, but it's not responding for some reason. Let's see. All the others are responding except this one. So we might have incorrectly placed that rectangle, or its coordinates might not be correct. So let's see, bottom mid box. So yes, so yeah, this is why I said it's very important to have these things set up correctly. So as you can see, it doesn't register my click in here, so that's an issue. So now that it's fixed, I'm just going to run it again and make sure that all of the boxes register. And as you can see, it does. But this doesn't look that great because we can't see the lines which we drew in the previous video. So what is the point of having the lines? So what we can do is we can shift these images and we can scale them down so that we can see both the lines and the X's and the O's. And another thing is we don't want to place another X or O on top of the previous one. So if someone plays here, you wouldn't want them to override what you have. So we're going to fix those two things. The first is we're going to scale the images and place them properly. And the second is we're going to prevent multiple plays on a rectangle. So let's do that quickly. So now this is where we're placing the X's and O's. And before we get into that position, we can come up here where we load the images to scale them. And we're going to scale them down and try to define what we want them to look like. Okay, so we can now say X image equals Pygame.transform, and you can go to the Pygame docs, which I also have in description, to figure out how each of these functions that we use work. So if you're not sure how any of these things work, so let's say you're not sure how Pygame image load works, you can just look it up on Google or go to the docs directly, search for that, and it explains each of the attributes you can pass into it and stuff like that. So now we're using scale, and here I'm going to change these into that size essentially. So 60 by 60, and I'm going to do the same for the O. So now I'm going to change the O as well. So I'm going to transform, then scale this image and have it as 60 by 60 as well. Okay, let's see if that makes a difference. So let's run it quickly. All right, so we're going to put that. Okay, cool. So they're much, much smaller, but if you look at them, they go towards the top left corner and they cover part of the line, and they're not particularly in the middle. So to fix this, you can do some math or you can play around with some values. I played around with some values and I discovered that if I can just add 20 to each of the positions that I pass in here, then I get near perfect placement. So if I add 20 to the X and Y coordinates of the rectangles or the top left corner where I'm supposed to place the X's and O's, I found that it looks decent. So let's check this again. So if you look at that placement, that's fine to me. It's not touching any of the lines, and the white background helps because the images also have a white background and it looks like it just fits right in the middle. So that's a quick fix over there. But we still have this issue where we are able to override what's already on the screen. So let's fix that. And to fix that, we're going to keep track of each of the positions. So let's do it this way. I'm going to define an array that keeps track of the board. So let's call this keeping track of filled positions. Filled positions on the board. I can say keeping track of the board. I'm going to call it board, and it's essentially a 2x2 matrix or 2D matrix. It's not a 2x2, it's actually a 3x3. So this would have each of the positions on the board defined as a string. And it helps that we define the turn as a string as well, because we're going to use that to fill these positions. And what I mean by that is each of these strings represents the board. Remember, we have 9 positions or 9 rectangles. And whenever we play or whenever we place something on the board, we can just update that position in this array. And then we can check if that position is populated, if there's something there. So if there's something there, then we can't play in that position. So let's quickly make those changes so that we can make sure that if we're playing in this section and not board, which basically makes sure that we are not playing in that specific position. So if you go on the 3x3 grid, or if you go on the board, position 00 corresponds to the top left. So it corresponds to that. Then 01 corresponds to that. 02 corresponds to that. Then 10 corresponds to that, and so on. So using a 0 index here as well. So the top row starts with a 0. Second row starts with a 1. This starts with a 2. Then this column is a 0, and so on. So we're describing the row and the column on the board, and we're making sure that there's nothing there. That's why we're using this, right? And not that, to ensure that there's nothing there. So if you clicked in this section and there's nothing there, then you can place something. So if you're in the section, but there's something there, this will fail and it will not go to the next line where it places the X or the O. So you won't be allowed to play them. We're just going to go ahead and fill in each of these positions. I've already described them in terms of the board and the positions. So I'm just going to copy this over and over again, and then I'm just going to edit the coordinates of each of these positions, and you can figure those out yourself. So you can figure out that 00 is the top left, and then 01 will be the top right or top mid, and then top right would be 02, and so on. Okay, so I'm just going to fill in the row. So row 0, the first one, column 0, row 0, column 1, or the second one, and row 0. So that's how it works, essentially. Now we're going to the second row, and the first column, second row, and second column. And we have the second row, third column. Then we have the last row, which is the third row, first column. Then we have the third row, second column. And finally, the third row, third column. So since it's 0 indexed, it's one less of wherever it is. So row 0 is actually row 1, and column 0 is column 1. So now let's see if this worked. So we did all of that just to prevent a user from clicking twice in a position. So if I place an X there and I try to click there again, it still places that there. And that's because we haven't been updating the board. So there's nothing in the board. The board is still empty, or there's still empty strings in the board when we play. So we're supposed to now replace that here. So we can add it here as well, just to give the position whoever's turn it is, or whoever's playing at that point. So at this position, we're going to pass in whoever's turn it is. So if X is playing, you're going to fill that position there with X. And if O is playing, then just going to fill it with O. So we can do it like this essentially. And that should just fill in that position, because if we just check for this, it'll never be filled up and the state doesn't change. But if we update that board as we play, then it will also allow us to have these checks, or these checks will be valid. So now let's do this, that there. So remember that turn holds X or O. So whoever is playing now, currently, if we place an X, that's what's going to be filled in there. Okay, and we are done. So let's run it one more time and hope this works. So X, and if I try to click in there, see nothing happens. Click somewhere else, okay, it's fine, but it still says X. It's supposed to say O. So what is wrong with that condition? Okay, where is this? And is it aligned with everything else? That is the question. Okay, I must click there, positioned it there. So it seems to have changed turns, even though we didn't place anything there. So it's only supposed to change turns if something was placed on the board. Okay, so that's very interesting. So we might actually have to put this in there. So after placing that, let's define a function then. Let's do that just to make sure that that doesn't. So let's say change turns. And then we're going to put this in there so that we don't have to copy it over and over again. So where's that function? It is over here. Okay. So we're just going to call this function and change turns whenever we place something. But if you don't place anything on the board, it doesn't make sense for us to change turns. So after placing this on the board and updating our string board as well, we're going to change turns, because it appears that it allowed us to change turns even though no moves were made on the board. So you only want to make that possible if we do change turns. So what did we do? Cannot access local variable turn. So should we call it global? Let's see if that helps. Okay. Then when we start the game, or right after this, I guess, we can give it a value of X. So just change that to, let's see if this helps, if that works before we conclude. Okay. So there's an issue with that. It says can access local variable when it's not associated with a value. Okay. So let's debug. Let's fix this. Okay. Okay, where can we properly place this? Okay, so the issue is, I think that's the issue. I didn't know which turn we were referring to because it's just floating up there somewhere, and we can't just start using a variable which is not defined. So hopefully this works. So you can keep the turn. Let's just run it and confirm first before I explain how we. Okay. So you can keep this turn defined as it was, but in this function, which I just have there, just say global turn so that it knows that the turn you're referring to here is global. If you leave this out, where is turn coming from? In this function or in this local scope, we haven't described or defined turn, so we wouldn't know what it is. So in here, you just do that so that it knows you're referring to the turn which you defined in the global scope up here or outside any of the functions. So that should fix that. And let's rerun this again. And that is our solution, I believe. So we had a bit of debugging in this video. That's cool. So that's an X. And when I click here, it doesn't allow me to put in an O. And when I move on to another block, I want it to be an O. It should not have changed turns yet until I click on another one. And even in here, I can't click on that block and I can just continue playing. And now the board is full and I can't necessarily, let's see, it looks like these ones can be changed for some reason. Which ones are they? So the ones at the bottom can be changed. Let's see what the issue there is. Okay, so the issue is I copied the incorrect values on the board, as you can see. So the values here have to match the values here. The last one on that will be 1, 2, then 2, 0 there, then 2, 1 here. This is the problem with copying and pasting. And now 2, 2 over there. Okay, so let's run this again. And we fill the board up and nothing can be overwritten on the board. And we've confirmed that. All right. So now we haven't determined the winner. We don't know what's going on, whether it's a draw, whether someone won or anything like that. Well, there's a clear winner here. And that's what we're going to cover in the next section. In this section, we just basically defined these rectangular areas, and then we tracked our mouse clicks. And if a mouse click collides with any of the rectangular areas, that's where we place the X and the O. We scaled the X's and the O's, and we changed turns as well. As a bonus, we had some debugging which we had to do. So I hope you guys enjoyed this video and you're able to follow along. If not, just go back to the section which you didn't understand or leave a comment in the comment section. So I'll see you in the next video.